Report, where we uncover what's working and what's breaking on the internet and why. I'm Chris Villemez with ThousandEyes Technical Marketing, and I'm joined here today by Kemal, Principal Engineer at ThousandEyes. Welcome, Kemal.
Thank you. Good to be back to Internet Report.
Definitely, definitely. So we're going to unpack the recent Twitter outage event from March 28th and dig in and see what we found. Let's go ahead and get started. Okay, so this was an event that happened, I believe it started right around 12:07 or just under UTC on March 28th. It was an event that affected access to the Twitter service globally. Now, it didn't impact everyone around the world, but it impacted a decent number of folk in various locations. So I think this is a pretty interesting one to unpack. So what we're seeing right here is one of our tests that from Manchester, England location that it just does a really good job of catching this event, as you can see here. So this is a full page load test, and you can see, right prior to the event, everything is good. Manchester, England is green and healthy. And then the moment, this event starts, it's like a light switch, right? One thing I'll point out here, just so you can understand what this refers to in our product, this application outage feature. What this does is, as you may know, it provides, it's essentially an analysis of our millions of tests, that huge data lake of data that we get, and if it finds enough tests kind of corroborating a certain type of event, like in this case Twitter, it'll note it in our internet insights, our application outage feature. So you might see this here, and it's kind of a helpful thing when you're looking at your test. It says, hey, you're testing Twitter. Well, we happen to know a lot of tests around the world were failing at the same time, just kind of as an FYI. Of course, in our case, it maps pretty clearly, right? So
it also builds a confidence in what you are seeing, that you are not the only person that's seeing the outage. It's actually across our customer base. And to your point, it's millions of tests that are actually observing the same event.
Right. It's kind of almost like a form of crowdsourcing the fact that there's an outage, except for it's data driven, right? This is real world data that we've collected. We know something's happening. It's happened across X number of tests at the same time frame, and so we're going to inform you that this bigger event is going on.
Exactly. It's not sentiment based. It's actually data driven decision that goes into displaying this purple line.
Exactly. And here it pretty closely maps to that, just that light switch off moment that we can see here. Now, of course, you can see prior to the failure here, we have really good latencies for page load, sub 1 second, for this page to pull down. So that what that implies is from Manchester to the Twitter service is a pretty short path, right? So there's a lot of capacity from source to destination, and things are coming down in a timely fashion. Of course, it shuts off suddenly at this moment. We can kind of walk through some of the other layers of our test here. Of course, this is the basic HTTP server availability. And again, just like a light switch, it goes off right here.
And it's quite visible. And it's quite visible that within the 5 seconds, we were not able to establish TCP connection. Essentially what connect message error in this particular case indicates in our product is the fact that we were not able to establish three-way handshake, which means that connectivity was 100% down.
Exactly. So, I mean, that's and these errors, you can always look at and see, why did we fail? Why did we fail availability? And as Kemal noted, we couldn't even attach to a TCP socket. There's just nothing there listening for us to connect to in this particular path here. And of course, when we jump over, the nice thing about this particular test is, the equivalent to that valley of lack of HTTP server availability. We now have a corresponding mountain of packet loss, and in this case, it's 100% packet loss for this particular test. So, all 100% of those packets are failing to reach destination. We can jump over and see if we can get an idea of why. Actually, let's go ahead and step back just prior to the outage, so we can see what changed here. So again, this is our Manchester, England location. It's got a happy path here that's successful. It's going out London Internet Exchange links here. And if we walk up to the moment the problem began, and we can see quite clearly here that we're now being rerouted. So right here, we're going this path through Comstar, AS8359, and ultimately going into Russia now to try to get to the Twitter destination. Of course, that's not going to work. These ISPs are not servicing that Twitter, or providing that Twitter service. And so these packets are just going to die somewhere in this path.
Exactly. They are getting essentially black holed at that stage.
Exactly. And we can dig into that a little bit more here. Let's go ahead and jump over to a more nuanced test. This is actually a test that we have here that was a global test. We've got a total of 47 locations around the world. Of course, you can see here prior to the event, everyone's looking green and healthy, right? So let's just jump down to BGP and take a look.
Just before we do that, Chris, I would appreciate if you could click on HTTP server and click on the table view so that we can see the scope of the event.
No, good point. So this is, I believe, just prior to the event. So right now, everyone is still healthy. So you're seeing all 200 OKs. So let's just go forward.
Still healthy, yeah.
It's still healthy, and this should be when the event started. And of course, now we have a handful of locations failing, and you can see the reach of this, right? We've got Columbus, Ohio, and Germany, and Moscow, and Toronto, Canada. All of these locations impacted, whereas the vast majority of the world was still successful, right? So it's an interesting impact in the sense that it was geographically widespread, but still relatively limited in terms of the sheer number of users that would have been impacted.
And this limited scope of the event is actually quite clearly shown on our BGP path visualization.
Yeah, so let's go ahead and jump back to prior to the event. We'll jump down to see what's going on with BGP routing. So actually, let's just go back one more. So you see here, Twitter AS13414. They're very well connected. As we noted, they're connected directly with a lot of big name providers, a lot of tier 1 providers, and everything is healthy and normal routings as you would expect. So we jump up to when the problem started. Now, I'd like to point out one thing. So in this BGP route visualization, right now I'm looking at the metric of path changes. So this is going to be all those BGP updates that impact the IP path. So in this particular case right here, we know this update to be corresponding to a BGP update that was sent by RTCOM, and it was actually an announce for this Twitter prefix. And if we scroll down here, we can actually see RTCOM AS8342 has announced this Twitter prefix, essentially what we would refer to as a prefix misorigination, right? So RTCOM is obviously not the owner of this /24 Twitter prefix in question. That they're not authorized to essentially do this. It's basically an illegitimate action, right? They're announcing a prefix for which they are not the origin. And we can see that very clearly here. So this update went to Comstar, also known as MTS, after an acquisition a few years ago. So it went to Comstar. Comstar in turn sent this update out to their peers. And in fact, IPMax here, AS25091, actually updated their routing table. So they took this announce that was sent, this prefix announce that was sent by RTCOM, and made it their active BGP route in their routing table. And it's illustrated in our platform in the sense that this is now a solid line indicating a new route. And this hashed line or dotted line here is the former, what we know to be the valid route that's now been removed.
And what's quite interesting in this particular event is the fact that looking at the previous advertisement compared to the new advertisement from the RTCOM, it looks like a longer path got accepted. So if we click on view details of the path changes, you will see that the initial path is originated from the Twitter and it propagates directly to 25091. However, if we look at the what could be called hijack event in this particular case, the nature of this event, we can see that 8342, which is RTCOM advertises that to Comstar, and then it propagates that prefix to 25091 in Switzerland, which then gets accepted as the preferred prefix. Now, we know based on BGP rules that the only best prefixes are getting accepted, which means that at certain stage at 1206.31 UTC, this prefix was considered the best. So the question arises in the form of why would you accept longer prefix? Thinking about this event a little bit more, it looks like that RTCOM advertised this prefix to Comstar by their private peering, and that would be potentially the only use case as part of which you would accept a longer path to be your preferred path based on the BGP best path selection algorithm rules, right? So what happens is that you by default prefer the shortest AS path. However, in this particular case, we can see that's not the case. We have a longer path installed. And thinking about it from the operational perspective, we know that private peers are usually configured in a manner as part of which, a local preference is configured in a way to prefer prefixes that are learned by private peers, and this is what we believe is happening here. So 8342 is advertising this prefix, potentially even to other ISPs, but in this case, using the private peering towards the 8359, which is Comstar, and then which propagates there, as a result of which it gets installed, right? And the only other reason why would that be would be potentially the rules that are configured on the private peering. And why would you do that, right? That happens with the multitude of reasons, but most common are the fact that, it's cheaper to actually accept and prefer the prefixes that you are learning from the private peers compared to the transit. Now, why don't we see this event propagating a little bit more? That goes back to what, Chris, you already said, and that's the fact that Twitter is really well interconnected. They are peering with multitude of tier one providers, and by nature, it's hard to have better interconnectivity than them. So that's why we are not, among other reasons, not seeing wider propagation of this event further.
Yeah, and that's I think that's an interesting point. I mean, that's something that definitely helped Twitter here. Is just their if you take a look at Twitter's 13414 autonomous system in Looking Glass, they just have a huge number of connections to a large number of tier one providers. So at the end of the day, that AS path is going to typically be shorter than anything RTCOM could have come up with. And it's still going to be preferred, even were they to have received this ultimately invalid route. In the case of some of these more nuanced BGP policies, and in the case of this private peering relationship rather that Kemal discussed, of course we have a scenario where AS 25091 did indeed accept and update the routing table and pass this on. But by and large, Twitter would have been I think protected pretty well just by the sheer connectivity.
There are also other things that potentially Twitter had working in their favor when it comes to this event. Prior to this event, we were actually checking the signature of this prefix. So we know that RPKI, or that, there's a signature on this particular prefix. So all the providers that were enforcing or doing ROA checks were actually potentially dropping these prefixes from the peer that should not be advertising this, in this case, obviously RTCOM, because it's a signed prefix. So if you're enforcing the rules, you should be fine and protected, or your down the line connectivity should be protected. Unfortunately, RPKI is still not widely adopted. So it comes down to who is enforcing and who is not enforcing. But I believe that this is partially something that went in a favor of Twitter when it comes to this event.
Oh, absolutely. I would agree. It's again a little hard to quantify exactly how much, but it clearly would have helped some. I mean, Twitter took they took that good step, right? And I can't say this enough to encourage the usage of our route origin authorization and RPKI mechanisms. But Twitter they took the good step to digitally sign this prefix. Anyone that was validating that origin authorization and using RPKI would have known to reject that route. So that's certainly something that would have helped them here as well.
But yeah, like Twitter had really good two things working for them here. The first, the fact that they are very, very, very well interconnected with tier 1 providers, which made it really hard for the hijacker in this particular case to have better interconnectivity to the rest of the internet, which is actually quite interesting that they still managed to affect few of them, right? But that's what it is. There's no solution that can encompass all the ISPs on the planet. And then the other thing is RPKI, I would say that did a piece of trick as well.
Yeah, no, absolutely. And let's just, while we're in this view here, so we can see here what's really interesting about this is this we caught exactly two path changes right here. You can see this one corresponds to that BGP update message with the prefix announcement, and then if we go over to here, this right here corresponds with RTCOM issuing a withdraw for that prefix. So they've presumably recognized their mistake or were informed by a knock or something calling in and corrected by removing that route. And we can see this down here. Again, RTCOM has sent out a BGP update with a withdrawal for that prefix. And note here that these lines are now dotted, indicating that these other autonomous systems have preferred the old path, basically. So they're reverting back to the good path and removing the incorrect path. So ultimately, RTCOM ended this with a withdrawal of that prefix. Now, one thing that's interesting, and I want to point out here, is that while we saw the vast majority of the impacted regions around the world not recover, in fact, until this withdrawal. That's in fact why we saw, if you recall over here, it just looks like a valley, right? Like a light switch. Right here is this timestamp here is when that withdrawal finally propagated out and allowed this to work. So if we look at path visualization, though, oh, sorry, we'll go to this one. If we look at path visualization here, we know that Columbus, Ohio was impacted here. We can scroll down and find it. We just got a few, right? We've got Moscow, we've got Leipzig, Germany, Toronto, Canada. Actually, let me just find it in here. So Columbus, Ohio, prior to the event, let's just take a quick look here. They have a normal, healthy route. They're actually utilizing level 3 to get to the Twitter service. Here is when the impact begins. This is again that announced prefix origination rather that went out. It got to as far as Columbus, Ohio, and we see we're now routing through Comstar, right? So we're now going to Russia. We're going the invalid path. Now, we know that the announce was not until the withdrawal was not until 12:45 UTC. But if we take a look here, we see more or less midway through the event, Columbus, Ohio is successful. So I think this is an interesting example to kind of segue into here. What can Twitter do to try to alleviate this themselves, right? So they're, whereas we see that some locations, they had to wait for RTCOM to remove the offending route, right, before their service was restored. In this case, we see the Columbus path restored prior to that. So I think this is a what kind of things can organizations? What actions can they take, Kemal, when under this type of a thing, either a route hijack or a BGP route leak or something that's impacted your service delivery, but yet is outside of your control?
The most common thing that companies do when it comes to hijacks or leaks, for that matter, is to check which prefix is obviously getting hijacked or leaked, and then identifying what more specific prefixes can be advertised. So, for example, if you are dealing with /23, you are going to break it down into /24s, and you are going to advertise those more specifics, because we know that that's the way that typical networking works, right? You are going to prefer always the longest match. So that's the usual fix. However, in this case, as in many other cases, especially nowadays, during this time, as part of which IPv4 is getting exhausted, right? A lot of companies are advertising /24s, which is the longest prefix that you can advertise these days that ISPs are going to accept, right? So that option of deaggregating prefix and sending more specific wasn't the case here, which usually would be the first operation. That's the last option that you have in this particular case. That's directly in your scope of what you can do from the network engineering perspective. However, alternative to that is actually picking up the phone and calling the ISP that is propagating your prefix. In this case, what seems to have happened is that probably network operations team from Twitter or Segwit Reliability Engineering or network reliability engineering team picked up the phone and called level 3 and actually asked them to filter out this advertisement, which potentially made Columbus, Ohio, to recover faster than it usually would. Now, in this particular case, we are dealing with approximately 30 minutes of outage, right, rather than 45. But that's still, depending on how criticality of your application, that's still, quite important. You don't want your prefixes to be inaccessible for your end users. That's the, full point of it. So I think that's what we are seeing right here.
And plus, it should be noted, I think at the time we couldn't have known that RTCOM was going to withdraw that route. I mean, it's we can't speculate on their intent necessarily, but we can we know what happened, and we can't know if it was going to be removed right away, or we can't know that it was going to be removed in 45 minutes, right? So, not knowing that, you have to try to do what you can to try to restore access. And again, as Kemal noted, prefix deaggregation wasn't an option. We're not going to be able to start advertising out /25s in this case, because providers aren't going to accept that long of a prefix route. So they were really limited, essentially, to option number 2, and that's to engage ISP. Now,
it's quite important to note here that this is an event that lasted for 45 minutes, which is quite a long period of time, but obviously it could have been lasting, for much more than it did, right? But imagine this event happening for one of our financial customers, right? You're not only dealing with the consequences of not being able to serve your customers, and that's pretty sensitive stuff. You are now dealing with the, compliance-related reasons, as part of which, controllers are looking at you and saying, what did you do to prevent this kind of stuff? Did you have sufficient alerting in place to detect it as soon as it happened? And, what were your recovery steps? So, having visibility such as this one is not just important to know what happened. It's actually important to enforce certain actions on events once they occur.
Yeah, I mean that's really important to note. I mean, as you know, to use the overused phrase, I mean, time is money, right? And this it really truly is, especially in these digital services when they're down. And you know, if I'm an operator of a digital service and I'm in this type of a scenario, I mean, I'm going to be scrambling to do what I can. And in fact, it's quite conceivable that and likely that Twitter had preparation, right? They had their list of contacts with their upstream providers. And they, hey, when I'm in this type of event, here's going to be my course of action. But the key here, I think, is having that detection capability, right? If I don't know this is happening until users start to complain, I've lost a lot of lead time in trying to get myself out of this scenario. So
and in general, like knowing about your event from your customers is possibly the worst case scenario, right? That's the last thing that should happen to anyone.
Oh, absolutely. Yeah. You don't want to find out by customer complaint. You want to catch this with your own detection mechanisms. And even in this type of scenario where it feels like your options might be limited, I can't do prefix deaggregation. I can't, announce longer prefix routes to try to take some of that hijack traffic back to me. What else can I do? Well, the good solution is to start reaching out to those ISPs and to make sure you have that as your kind of mitigation and reaction process, have all that contact information and so forth. And it clearly helped. We can see here in this particular scenario, because some locations, in the case here of Columbus, Ohio, restored prior to RTCOM removing that. Now, I think at the end of the day, RTCOM was doing some type of manipulation of traffic with BGP, whether it be error or not, and then they did correct it, right? They did issue that withdraw, but again, that's a fairly lengthy time to have your service down when this is the case. And I think some of the takeaways here is just number one, if you are doing something, let's say a legitimate use of BGP traffic redirection, like a distributed denial of service, a kind of a black hole routing type of thing, make sure you're using those well-known communities, no export or no advertise, just to make sure that this doesn't, risk impacting the broader internet, pollute the global internet routing table. And then of course have that detection capabilities, that end-to-end visibility, and just have a plan. You have to know what you're going to do once this is detected, and how do you try to resolve.
And we are not saying that it happened. It's just like that you should have the policies that are proven to work in these kind of scenarios where you are doing traffic engineering. So what do you want to do? Whether you want to influence ingress, egress, or something like that, those should be really tested policies. Or you should potentially, even invest in automation as part of which, you're going to execute script for certain prefix that's going to know, details about your environment, and based on that, craft the policy itself, and push it outwards, so that you don't end up in a situation where you mistakenly push this update to your private peers, if that was not intended, right? So that would be the first one. The second thing that I would say also is that, events such as this one, over and over again, just indicate requirements for everyone pretty much to participate in RPKI. It's invented it's invented for a good reason, and we should see a wider internet community adopting it at faster pace, even though really significant steps have been taken in that in that direction. Also, things such as filtering, right? There are databases that should, explicitly indicate, what should be filtered out, and what should go through, right? And enforcing these policies based on these things should be, and it is considered best practice. So, participating in filtering based on the database entries for certain ISPs should be something that's done. And lastly, I would say, Chris, that this event, such as many other ones, really outlines the importance of end-to-end visibility, right?
Yeah. So no, absolutely.
knowing what's happening and when it happens, being proactively alerted on the event such as that one, having easy to access dashboard, where you can observe what's happening so that you don't scramble when even such as this one strikes, impacts the mean time to resolution, and that's the big one that everyone speaks about. MTTR is something that, ideally every company should, strive towards. And, when it comes to even such as this one, identifying what's happening is crucial. Having dashboards and alerts that indicate that it happened when it happened is must-have at this stage, and then having a playbook on what to do when it happens is, something that pretty much every single NOC or NRE team should have at this stage.
Yeah, no, absolutely. I think having first having that plan in place ahead of time, having the monitoring so that you do get that quick detection. You do catch when something is going off outside a baseline, and backing it up with this quantifiable data with like things like user experience monitoring, end-to-end monitoring of performance and path performance and all of these sorts of things. Having that visibility and having that data to kind of guide decision making and ultimately working yourselves out of these problems once you're in them, because honestly they can be a pretty scary sort of thing to be dealing with. So I think that wraps it up. That's our show. Again, don't forget to like and subscribe. And if you do subscribe, we'll send you a free t-shirt. I think it might be something like this maybe, or maybe even cooler. So just go ahead and drop a note to internetreport@ThousandEyes.com. Again, that's internetreport@ThousandEyes.com with your address and t-shirt size, and we'll get one over to you. Thanks again.
Thanks, bye.